All right, let's go. Number 10, the frilled shark. In 1884, German ichthyologist Ludwig Döderlein returned from Japan with a specimen unlike anything in the scientific record. The creature was eel-like in shape, nearly 6 feet long, with a flattened serpent's head and rows of teeth that defied classification. He cataloged it under a name that would later be revised to Chlamydoselachus anguineus. The frilled shark. What he had brought back wasn't just a new species. It was a creature whose lineage extends back roughly 80 million years, surviving virtually unchanged since the age of the dinosaurs. The frilled shark lives between 500 and 1,500 meters below the surface, drifting through the cold water column on continental slopes around the world. Most people will never see one. Most people who study marine biology for a lifetime will never see one. The animal exists in a region of the ocean where sunlight has never reached, where pressure crushes ordinary objects into ruin, and where the rules of biology bend toward the unfamiliar. What makes the frilled shark particularly unsettling is its mouth. The jaw is lined with approximately 300 needle-thin teeth arranged in 25 rows. Each tooth has 3 sharp prongs, designed to hook into prey and prevent escape. Once something enters that mouth, the geometry of the dentition makes withdrawal nearly impossible. The shark doesn't bite in the conventional sense. It strikes forward with its body coiled like a snake, lunging the entire upper torso toward prey, and the jaw pulls the victim inward through a wall of inward-pointing teeth that function less like a bite and more like a one-way trap. The animal's diet consists of squid, smaller sharks, and bony fish, all of which are swallowed whole. But here's where the nightmare deepens. The frilled shark has the longest known gestation period of any vertebrate on Earth. Pregnancy lasts approximately 3.5 years. The embryos develop slowly in the cold and the dark, drawing nutrition from yolk sacs because there is no placental connection. By the time the young are born, they are already capable predators, miniature versions of the adult, equipped with the same triple-pronged teeth and the same hunting instincts. They emerge into a world that hasn't changed in 80 million years. The truly horrifying aspect is what the frilled shark represents. It is not a relic in the sense of being weakened or outdated. It is a design that worked so well it never needed to evolve. While dinosaurs rose and fell, while continents drifted and ice ages came and went, while every other shark species on Earth was forced to adapt or vanish, this animal kept its body, its teeth, its hunting style, and its slow, patient gestation cycle. Whatever the conditions of the deep ocean were 80 million years ago, they remain similar enough today that the frilled shark requires no upgrade. The implication is heavier than it first appears. We tend to think of evolution as forward motion. The frilled shark proves that some environments don't move at all. Beneath the waves, in the perpetual dark, time has stopped, and the things that live there are exactly the same as they always were. Number 9, the goblin shark. In 1898, a Japanese fisherman pulled an animal from waters near Yokohama that was so unusual the scientific community initially questioned whether it was real. The body was pale pink, almost translucent, with visible blood vessels beneath skin so thin it appeared diseased. From the front of the head extended a long, flattened blade, like a deformed sword, and below it a jaw that looked separate from the rest of the skull. The specimen was sent to American zoologist David Starr Jordan, who recognized it as something genuinely new and gave it the name Mitsukurina austoni, the goblin shark. The species had likely existed for over 125 million years, and almost no human had ever seen one. The goblin shark lives between 900 and 1,300 meters below the surface, in waters so dark that vision is largely useless. The animal's pink coloration isn't a trait for camouflage. It's the result of blood vessels showing through skin that lacks pigment, because at these depths, there is nothing to hide from with color. The flat snout protruding from the head is studded with electroreceptors called ampullae of Lorenzini, organs that detect the faint electrical fields generated by the muscle movements of prey. The goblin shark doesn't see its food. It feels it. In total, darkness. Every fish that twitches sends out a signal, and the long, pale snout reads those signals like a scanner. What makes the goblin shark particularly disturbing is what happens when it strikes. The jaw of this animal is not fixed to the skull in the way most sharks' jaws are. It is connected by elastic ligaments that allow the entire mouth to launch forward. When prey is detected, the goblin shark fires its jaw outward at a speed of roughly 3.1 meters per second relative to its head, faster than almost any other fish on Earth. The mouth ejects from the body, snaps closed on the target, and retracts back into the skull. The motion is not a bite, it is an extension. The animal's face becomes a separate weapon that travels independently of the body, then returns. Footage of this behavior, captured on rare deep-sea expeditions, has been compared by marine biologists to the inner jaw of the xenomorph in the Alien films. The comparison is not exaggeration. The goblin shark predates that fictional creature by tens of millions of years. But the most unsettling detail is what the goblin shark tells us about the limits of our knowledge. The species has been documented for over a century. We know its anatomy, its hunting mechanism, its general range. What we do not know is almost everything else. We do not know how many there are. We do not know how long they live. We do not know where they breed, when they reproduce, or what the juveniles look like in their natural environment. Almost every specimen we have was caught accidentally by deep-sea fishing operations, dragged up from a world we cannot reach. The goblin shark exists, and we have its body in formaldehyde jars in museums around the world, but it remains functionally invisible. There is an apex predator with a launching face hunting in the dark beneath us, and we have almost no idea how it lives. Number 8. The giant isopod. In 1879, French zoologist Alphonse Milne Edwards was examining specimens dredged from the Gulf of Mexico when he encountered something that initially appeared to be a mistake of scale. It looked like a common woodlouse, the kind of small armored crustacean found beneath rocks in gardens, except this one was the size of a small dog. The body was pale, segmented, encased in overlapping armored plates, with 7 pairs of legs and 2 enormous compound eyes set on either side of a flat triangular head. Milne Edwards classified it as Bathynomus giganteus, the giant isopod. The animal lives between 550 and 2,150 meters below the surface, and it is the largest known isopod on Earth, capable of reaching lengths of 76 centimeters and weights of 1.7 kilograms. The giant isopod inhabits the abyssal plains of the world's oceans, regions of cold mud and sediment where almost no light penetrates and temperatures hover near freezing. It is not a hunter in the conventional sense. It is a scavenger. Its primary food source is the bodies of dead animals that sink from the upper ocean, what marine biologists call marine snow at the smaller scale and whale falls at the largest. When a corpse drops to the seafloor, giant isopods detect it through chemoreception, sensing the chemical signatures of decomposition through the water. They emerge from the sediment, sometimes in the dozens, and converge on the body. They feed slowly, methodically, gnawing through flesh and bone with their mandibles for days or weeks until nothing remains. What makes the giant isopod particularly horrifying is its metabolism. The animal can survive without food for extraordinary periods. In 2007, an aquarium in Toba, Japan acquired a specimen and placed it on display. The isopod stopped eating in 2009. It refused all food offered to it. It did not die. For 5 years, the animal remained alive, motionless on the floor of its tank, neither eating nor showing signs of deterioration. It finally died in February 2014, having gone 5 years and 1 month without consuming anything. Researchers have proposed that giant isopods can enter a state of metabolic dormancy, slowing their bodily functions to a level that approaches suspended animation. Their cells continue to function, but barely. They wait. But here's where the nightmare expands. The giant isopod's primary feeding strategy depends on whale falls, the bodies of dead whales that descend to the abyssal floor. A single whale fall can sustain a deep sea ecosystem for decades. Hundreds of giant isopods may converge on a single carcass, feeding in shifts, consuming the soft tissues first, and then working their way through the cartilage. The image is difficult to process. In the perpetual darkness of the deep ocean floor, on a corpse the size of a school bus, dozens of armored crustaceans the size of dogs are crawling over the bones, methodically stripping them clean. They have been doing this for at least 160 million years. The body plan of the giant isopod, the segmented armor, the pale color, the slow patient hunger, predates the rise of mammals. While our ancestors were small nocturnal creatures hiding from dinosaurs, giant isopods were already crawling across whale-sized corpses on the abyssal floor. They were perfected before we existed. They will continue long after we are gone. And right now, beneath every ocean on Earth, they are waiting in the dark for the next body to fall. Number 7. The vampire squid. In 1903, German marine biologist Carl Chun published a description of an organism dredged from the deep waters of the Atlantic that he could not initially classify. The creature had 8 arms like an octopus, but 2 retractable filaments like a squid. Its body was deep red, almost black, and the webbing between its arms gave it the appearance of a living cloak. Its eyes were proportionally the largest of any known animal relative to body size. Chun named it Vampiroteuthis infernalis, which translates roughly to vampire squid from hell. The taxonomic name was not rhetorical. He believed the appearance of the animal warranted the description. The vampire squid is not actually a squid. It belongs to its own order, Vampiromorphida, which represents an ancient lineage that diverged from squid and octopuses approximately 165 million years ago. The animal is the only surviving member of that order. Every other relative is extinct, known only from the fossil record. The vampire squid lives between 600 and 3,000 meters below the surface, in a region of the ocean called the oxygen minimum zone, where dissolved oxygen levels are too low for most animals to survive. It thrives there. Its blood contains a specialized form of hemocyanin that binds oxygen with extreme efficiency, allowing the animal to function in conditions that would suffocate almost any other complex organism on Earth. What makes the vampire squid particularly disturbing is its defensive behavior. When threatened, the animal does not flee. It inverts itself. The cloak-like webbing between its arms is lined with rows of finger-like projections called chiri, which are tipped with sharp spikes. When alarmed, the vampire squid pulls its arms up over its body, turning itself inside out, exposing the spiked interior of the cloak as an outward-facing wall of needles. The animal becomes a sphere of teeth. From the perspective of a predator, what was previously a soft, drifting body has transformed into something armored and threatening, with the eyes still visible at the top, watching. The behavior is called the pineapple posture, and it has no equivalent among any other living cephalopod. But the most unsettling aspect of the vampire squid is what it eats. For decades, scientists assumed the animal was a predator, hunting small fish and invertebrates in the dark. They were wrong. In 2012, researchers at the Monterey Bay Aquarium Research Institute published findings showing that the vampire squid is not a hunter at all. It is a detritivore. The animal extends its long retractile filaments into the water column and collects marine snow, the falling debris of dead organisms, fecal matter, and decaying organic material from the surface waters above. It scrapes this material onto mucus produced on its arms, rolls it into balls, and eats it. The vampire squid lives by consuming the rotting refuse that drifts down from the world of the living. It is not a hunter. It is not even a scavenger in the traditional sense. It is something that drifts in the dark, mouth open, eating what falls. And it has been doing this since before flowering plants existed on land. Number 6. The barreleye fish. In 1939, marine biologist Chapman discovered a small fish in the deep waters off California that defied basic anatomy. The body was unremarkable, dark and elongated, but the head was different. The skull was capped by a transparent dome, like a glass canopy, and visible inside the dome were two large green eyes, tubular in shape, pointing straight upward. The fish was named Macropinna microstoma, eventually classified within the family Opisthoproctidae, the barreleys. For nearly 70 years, scientists studied dead specimens and assumed the eyes were fixed in place, locked in an upward gaze. They were wrong about almost everything. The barreleye fish lives between 600 and 2,500 meters below the surface, in a region of the ocean where the only light comes from above, the faint downward glow of distant sunlight diffusing through the water column. Below this depth, the world is fully black. The fish exists at the boundary between the dim and the absolute, and its anatomy is engineered for that boundary. The eyes are barrel-shaped, oriented vertically, and contain a retina optimized for detecting the silhouettes of prey passing overhead against the faint glow of the surface. From below, almost any animal in the upper waters appears as a dark shape against light. The barreleye watches that ceiling. It hunts what crosses it. What makes the barreleye fish particularly unsettling is what was discovered in 2008. Researchers at the Monterey Bay Aquarium Research Institute captured the first live footage of the animal in its natural environment, and the recording revealed something no one had suspected. The transparent dome on top of the head is filled with fluid, and the eyes are not fixed. They rotate. The barreleye can swivel its eyes inside its own skull, redirecting its gaze from straight up to forward without moving its body. When it spots prey above and lunges to feed, the eyes rotate to track the target through the strike. The dome is not a static window. It is a living display case, allowing the eyes to pivot freely while remaining protected by transparent flesh. But here's where the nightmare deepens. The barreleye's anatomy implies something darker about the conditions of its world. The transparent dome exists because the animal needs to see through its own head. The eyes are tubular because they need to gather every photon from the faint light above. The body is dark because anything visible would be silhouetted from below by the same light the barreleye is using to hunt. Every feature of this fish is a response to a single environmental fact. In the deep ocean, light comes only from above, and survival depends on watching that light without being seen against it. The barreleye is what evolution produces when an animal has to look up forever, in perfect silence, while remaining invisible to whatever might be looking down. It has been doing this for tens of millions of years. It will keep doing it long after the species above it have changed beyond recognition. In the dim layer where light dies, there are eyes inside transparent skulls, watching everything that swims overhead, waiting for something to fall into the dark. Number 5. The black swallower. In 1864, Danish zoologist Christian Frederik Lutkin examined a specimen pulled from deep waters in the North Atlantic that initially appeared to be deformed. The body of the fish was small, no more than 25 centimeters in length, dark and unremarkable from the head to the gills. But the abdomen was grotesquely distended, swollen to several times the normal proportions of the animal, stretched so thin that the contents inside were visible through the skin. Inside the stomach was another fish, intact, longer than the swallower itself. Lutkin had encountered Chiasmodon niger, the black swallower. The species lives between 700 and 2,750 meters below the surface, drifting through the cold mid-water column where prey is rare, and the rules of feeding bend toward desperation. The black swallower's body is built around a single function. Its jaw is hinged at the back of the skull and lined with sharp inward-pointing teeth that grip prey and prevent retreat. Its stomach is elastic to a degree that has no parallel in the animal kingdom. The fish can swallow prey more than twice its own body length and up to 10 times its own body mass. It accomplishes this by walking its jaws over the prey, using one side of the mouth to grip while the other releases and advances, gradually engulfing animals far larger than itself. Once the prey enters the stomach, the abdominal wall stretches to accommodate the volume, becoming so thin that the swallowed animal can be seen curled inside, sometimes still partially intact for days after consumption. What makes the black swallower particularly disturbing is the consequence of its own design. In the deep ocean, food is scarce. The swallower's strategy is to consume anything it can catch, regardless of size, because the next meal may not arrive for weeks. But the strategy has a flaw. The animal cannot digest prey large enough to fill its expanded stomach quickly enough to keep pace with decomposition. When the meal is too large, bacterial breakdown begins inside the stomach before digestion can complete. The swallowed fish rots. Gases accumulate inside the swollen abdomen. The black swallower, still alive, begins to inflate from the inside as its meal decomposes within it. The internal pressure eventually ruptures the stomach wall or floats the animal to the surface, where it dies. Most specimens recovered for scientific study were discovered exactly this way, floating dead at the surface, killed by the gases produced by their last meal. But here's where the nightmare deepens. The black swallower's body plan is not an accident. It is a calculated evolutionary gamble in an environment so empty that the animal must risk death every time it feeds. In the upper ocean, predators eat regularly and discriminate between prey sizes. In the abyss, food drifts past so rarely that any encounter must be exploited fully, even at the cost of the predator's own survival. The black swallower has chosen a strategy where every successful hunt may also be the last. The fish swims with its stomach full of something larger than itself, slowly digesting, slowly bloating, slowly approaching the threshold at which its own meal will kill it. The deep ocean produces this kind of animal. A predator whose anatomy is engineered to consume prey, it cannot survive. There are creatures in the dark that have eaten themselves to death repeatedly across millions of years. And the species continues, because the alternative is to starve. Number 4. The gulper eel. In 1882, an expedition aboard the British research vessel HMS Challenger recovered a specimen so unusual that the catalogers initially questioned whether the body had been damaged in collection. The animal was nearly 2 meters long, but almost all of that length was tail. The body was a thin black whip, ending in a small bioluminescent organ that glowed faintly in the lab. At the front, where the head should have been, there was instead a mouth so disproportionately large that it appeared to be the entire animal. The species was eventually classified as Uropharynx pelechinoides. The gulper eel. The animal lives between 500 and 3,000 meters below the surface, in a region of the ocean where prey is so scarce that body design must be rebuilt around the act of catching food. The gulper eel is almost entirely jaw. The mouth occupies roughly 1/4 of the total body length and hinges open like a pelican's pouch. The lower jaw is unfused, allowing it to expand laterally to swallow prey several times the diameter of the animal's head. Behind the mouth, the body tapers rapidly into a thin, muscular whip that ends in the glowing tail. The eel does not pursue prey in the way most predators do. It drifts through the water column with its mouth held open, waiting. When something enters the cavity, the jaw collapses around it. The eel does not need to chase. It functions less like a fish and more like a passive trap with a body attached. What makes the gulper eel particularly unsettling is the lure at the end of its tail. The tip of the whip-like body is equipped with a photophore, a specialized organ that produces light through chemical bioluminescence. The gulper eel can illuminate this organ at will, creating a faint red and pink glow that pulses in the surrounding water. In the absolute darkness of the deep ocean, any light is an attractor. Smaller fish and crustaceans, drawn by curiosity or the false promise of food, swim toward the glow. The eel curls its body forward, bringing the lure closer to its own mouth, and waits. By the time the prey realizes what the light is attached to, the jaw has already collapsed around it. The animal hunts using its own tail as bait against itself. But the most disturbing aspect of the gulper eel is what its anatomy reveals about the world it inhabits. Almost every feature of the animal sacrifices something normal in service of the mouth. The eyes are tiny and weak. The body has minimal musculature. The skeleton is reduced to a thin, flexible structure with almost no calcified support. There is no swim bladder, no streamlined hunting form, no defensive capability. The gulper eel is not built to survive. It is built to eat. Every organ system has been compressed, simplified, or removed to leave room for a mouth that occupies a quarter of the body and a stomach that can stretch to accommodate whatever the mouth captures. The animal is a living statement about the deep ocean. In the dark, where food appears rarely and unpredictably, evolution does not produce balanced creatures. It produces specialists. The gulper eel is what happens when a species becomes nothing but the act of swallowing, a body engineered around a single function so completely that everything else has been allowed to atrophy. It has been drifting in the dark with its mouth open for tens of millions of years. Number 3. The anglerfish. In 1837, Icelandic naturalist Frederick Faber described a specimen that had been pulled from cold deep waters in the North Atlantic. The body was round and bulbous, dark in color, with a wide flat mouth lined with translucent teeth that curved inward like glass needles. From the top of the head, a long, thin filament extended forward, ending in a small, fleshy bulb. Faber cataloged the animal under the order Lophiiformes, the anglerfish. The group eventually expanded to include over 200 known species, the most notorious of which inhabit depths between 1,000 and 4,000 meters and represent some of the most extensively studied and most misunderstood predators in the ocean. The anglerfish hunts using a method that has no equivalent above the deep sea. The filament protruding from the head, called the illychium, is a modified dorsal spine. At its tip is a bulb called the esca, which contains colonies of bioluminescent bacteria that produce a steady glow. The anglerfish dangles this light in front of its mouth, attracting smaller fish and invertebrates that mistake it for food or shelter. When prey approaches close enough, the jaw opens with such speed and force that water rushes inward, dragging the prey with it. The mouth closes. The translucent teeth, designed to admit prey but prevent withdrawal, lock the meal in place. The anglerfish does not chase. It waits, glows, and consumes whatever is foolish enough to swim toward the light. What makes the anglerfish particularly horrifying is what happens to the male. In most species of deep-sea anglerfish, the male is dramatically smaller than the female, sometimes only a fraction of her size. He is born without a functional digestive system. He cannot feed himself. He has only one biological purpose and a limited window in which to fulfill it. The male anglerfish drifts through the dark using his oversized eyes and chemoreceptive organs to detect the pheromones of a female. When he locates her, he bites onto her body and does not let go. His skin and tissue begin to fuse with hers. His circulatory system merges with the female's bloodstream. His eyes degrade. His internal organs dissolve. Within weeks, the male has become little more than a small lump of tissue attached to the female's flank, drawing nutrition from her blood and producing sperm on demand for the rest of his life. But here's where the nightmare expands. A single female anglerfish can carry multiple males fused to her body simultaneously. In recovered specimens, researchers have documented females with 3, 4, and in some cases 6 males permanently attached, all of them reduced to functional gonads with no autonomy, no perception, no individual existence. The males do not die in the conventional sense. They are absorbed. They become permanent biological appendages of the larger animal. From an evolutionary perspective, this arrangement solves a critical problem. In the deep ocean, finding a mate is so difficult that most males would die before encountering a female. Sexual parasitism guarantees reproduction once contact is made. From any other perspective, the arrangement is something close to horror. The male anglerfish exists for one purpose, achieves it through a process that erases him as an individual, and continues to exist only as living biological equipment attached to the body of a creature that has long since stopped registering him as a separate organism. Number 2, the big fin squid. In 1907, scientists examined a small juvenile cephalopod recovered from the deep Pacific and described it as a possible new genus. The specimen was incomplete and the description was tentative. For most of the 20th century, the animal existed only as a taxonomic possibility, a name attached to fragments. Then, in 2001, an unmanned submersible operating at 2,195 meters in the Gulf of Mexico captured video footage of an adult specimen drifting in the open water column. The recording revealed an organism unlike any cephalopod previously documented. 10 elongated, tentacle-like appendages hung from the body at sharp right angles, extending downward and outward in a configuration that resembled a chandelier or a spider on stilts. Each appendage was several meters long, suspended motionless in the dark. The animal was confirmed as a member of the genus Magnapinna, the big fin squid. The species inhabits depths between 2,000 and 6,000 meters, and almost no footage of it exists. The big fin squid is a creature defined by its proportions. The body itself is small relative to the limbs, measuring perhaps 30 centimeters in length. The fins on the mantle are large and translucent, giving the animal its name, but the defining feature is the appendages. The squid possesses 10 arms and tentacles that bend at sharp elbow-like joints and extend at right angles from the body. The appendages can reach lengths of up to 8 meters, making the total span of the animal roughly 26 feet. The squid drifts in the abyss with these limbs hanging motionless, presumably trapping or sensing prey that drifts into them. Researchers do not know exactly how the big fin squid feeds. They do not know how it reproduces. They have never observed it interacting with another member of its own species. Almost everything known about the animal comes from less than 24 recorded encounters. What makes the big fin squid particularly unsettling is its scarcity. The deep ocean is the largest habitat on Earth, occupying approximately 95% of the planet's livable space by volume. The big fin squid lives there. It must exist in significant numbers somewhere within that vast volume to maintain a breeding population. And yet, in over a century of deep-sea exploration, fewer than 20 confirmed sightings have been recorded. The animal is large. The animal is distinctive. The animal cannot be mistaken for anything else. And yet it appears to humans only in the briefest accidental glimpses, captured by cameras attached to submersibles, passing through the wrong section of water at exactly the wrong moment for the squid, and the right moment for the operator. But the most disturbing aspect of the big fin squid is what it implies about the rest of the deep ocean. If an animal this large, this distinctive, and this strange has been observed only a handful of times across the entire history of marine biology, what else exists down there that has never been observed at all? The deep ocean is vast beyond easy comprehension. The abyssal plains alone cover more area than every continent on Earth combined. The trenches descend to depths where no submersible can reliably operate. The big-fin squid is one of perhaps thousands of species that inhabit those regions, and it is one of the few we have managed to film. The implication is that almost everything living in the deep ocean is unknown to us. We have cataloged perhaps a fraction of what lives below 2,000 meters. The big-fin squid is not a rare anomaly. It is a glimpse of how much of the planet remains genuinely unexplored. Somewhere in the dark right now, larger and stranger animals are drifting in the cold, and we have no record of them at all. Number 1. The bone-eating snotflower worm. In 2002, a research team led by Robert Vryenhoek at the Monterey Bay Aquarium Research Institute deployed a remotely operated vehicle to examine a whale carcass at a depth of 2,893 meters off the coast of California. The whale had died months earlier and sunk to the abyssal plain, where its body had become an isolated ecosystem. As the cameras approached the skeleton, the researchers observed something that initially looked like a colony of pink flowers blooming directly out of the bone. The structures were soft, feathery, and waving in the slow currents. They were not flowers. They were animals. The team had discovered a new genus of marine worm, which they named Osedax, meaning bone devourer in Latin. Informally, the species would come to be called the bone-eating snotflower worm. They live exclusively on the skeletons of dead whales and other large vertebrates that fall to the deep ocean floor. The Osedax worm has no mouth. It has no stomach. It has no anus. It has no functioning digestive tract of any kind. The visible portion of the animal, the part that resembles a flower, is a feathery plume used for respiration, gathering oxygen from the surrounding water. The body extends downward into the bone of the whale skeleton, anchored there by a network of root-like structures. These roots secrete a powerful acid that dissolves the calcium matrix of the bone, allowing the worm to bore directly into the skeleton. Inside the roots, symbiotic bacteria break down the lipids and proteins released by the dissolving bone and convert them into nutrients that the worm absorbs through its skin. The worm does not eat in any sense recognizable to terrestrial biology. It dissolves the bones of the dead and lives on what its bacteria can extract from the residue. What makes the Osedax worm particularly horrifying is its dependency. The animal cannot survive on anything other than the bones of dead vertebrates that have fallen to the deep ocean floor. Its entire existence is bound to the death of larger creatures. When a whale dies and sinks, its body initiates a sequence of decomposition that supports a deep-sea ecosystem for decades. First, scavengers consume the soft tissues. Then, bacteria colonize the remaining flesh. Finally, when only the skeleton remains, the Osedax worms arrive. Their larvae drift through the water column for weeks or months, searching for the chemical signature of exposed bone. When they detect it, they settle, attach, and begin to bore. The roots spread through the skeleton, dissolving it from within. Over years, the bones of the whale are reduced to porous fragments and finally to nothing. But here's where the nightmare deepens. The Osedax worm exhibits a reproductive strategy that mirrors and exceeds the horror of the anglerfish. The visible worms on a whale skeleton are all female. The males are microscopic, smaller than the larvae of the females, and they live inside the female's body in clusters of dozens, or sometimes hundreds. Each female carries an internal harem of dwarf males that exist only as sperm-producing organs. The males never leave the female. They never feed independently. They never reach a size larger than a fraction of a millimeter. They are reproductive equipment maintained inside the body of the larger animal, identical in concept to the fused males of the anglerfish, but reduced even further in scale and autonomy. The most unsettling aspect of the Osedax worm is what it represents in the broader context of the deep ocean. The animal is a specialist. It exists for one purpose, on one resource, in one environment. It cannot live anywhere else. It cannot eat anything else. And yet it has thrived for at least 100 million years, surviving on the skeletons of vertebrates that have died and sunk to the abyss across the entire history of large marine animals. There have always been bodies falling into the deep ocean. There have always been Osedax worms waiting to dissolve them. They were consuming the bones of plesiosaurs and mosasaurs in the Cretaceous. They were consuming the bones of early whales in the Eocene. They are consuming whale bones now. They will continue consuming whatever falls into the dark for as long as large animals exist on Earth. In the perpetual cold of the abyssal plain, on every skeleton that descends from the world above, pink feathery flowers are blooming from the bones, and beneath the surface of those bones, microscopic males are floating inside the bodies of females who exist only to dissolve the dead. If you want to see more videos like this, click the video on screen now and make sure to subscribe.